Welcome. This is Mrs. Thompson, and today we're going to be talking about the double angle and half angle formulas. The objectives are here. The objectives are understanding the double angle formulas and half angle formulas and using these formulas. Your double angle formulas are here. Please pause the video, copy these, because you will be using them quite frequently. Note that there are three double angle formulas for the cosine of 2x. So in short, there are three things that can be substituted with the cosine of twice the angle. Moving forward to an example, directions. Rewrite the expression as the sine, cosine, or tangent of a double angle. Then evaluate the expression. The given problem is the cosine square of 11/12 pi minus the sine square of 11/12 pi. Notice that this problem is identical in format to the right-hand side of one of our double angle formulas for cosine. That means we can apply this formula. So our formula tells us that this is equal to the cosine of 2 times the angle. Our angle is 11 pi over 2, 11/12 pi, and that has to be multiplied by 2. After multiplying and simplifying the fraction, you get 11 pi over 6. Of course, we have to take the cosine of that, and the cosine of this angle is the square root of 3 over 2. Moving on to another example. This example is 2 times the tangent of negative pi by 8 over 1 minus the tangent square of negative pi by 8. As you can see, this original problem is identical to the right-hand side of one of our double angle formulas for tangent. So, we can evaluate this expression by rewriting it as the tan of 2x. Of course, x is time. X is always our angle measurement with our double angle formulas. So that angle is negative pi by 8. Multiplying it by 2. And simplifying, we get negative pi by 4. And the tangent of negative pi by 4 is negative 1. Moving on to our half angle formulas. Here I am sharing with you the half angle formulas for sine. These are also in your textbook. Please note that when your angle is in quadrants 1 or 2, the results of using this formula will be positive. But when your angle is in quadrants 3 or 4, the results of using the right-hand side of this formula will be negative. We also have the half angle formulas for cosine. Again, please pause the video and copy these as well. All of your double angle and half angle formulas you will be using regularly, especially in this section. And lastly, you have the half angle formulas for tangent. By the way, the formulas in this section, double angle and half angle, are sometimes referred to as identities. For tangent, there are 4 half angle formulas. So lots of things that we can substitute with the tangent of alpha over 2, the angle measurement divided by 2. So like with our other trig functions, please pause the video and copy these as well so they will be at your fingertips. Now, looking at an example of using the half angle formula to evaluate an expression. Expression is the cosine of pi by 8. Well, notice With the half angle formula, please pay close attention because this is an easy place to make an error or a little hiccup that will mess up your problem. Notice on the left-hand side, it is the angle divided by 2. And then on the right-hand side, whatever you're dividing by 2, that's what you take the cosine of. So on the left-hand side, this is really saying what amount divided by 2 is equal to the angle amount that's given to you in your original problem. So for pi by 8, it is pi by 4 divided by 2 that equals pi by 8. So the alpha value, the numerator value, is pi by 4. And that is the value we have to plug in on the right-hand side. So we have 1 plus the cosine of pi by 4 over 2 after that substitution. Of course, the cosine of pi by 4 is the square root of 2 over 2. Getting a common denominator and adding in the numerator. After doing so, performing the division. To perform the division, of course, since we have fractions, we invert the denominator, so it becomes 1/2, and multiply by the numerator. The results are here. And lastly, our denominator is a perfect root. The square root of 4 is 2. Since it's a perfect root, you should go ahead and evaluate it. Given a final answer of the square root of 2 plus the square root of 2 all over 2. Moving on to one more example. This time, we're asked to find the sine of 75 degrees. Remember, with the half angle formulas, you have to begin by finding what amount divided by 2 equals the original value given to you. And it is 150 degrees divided by 2. That equals 75 degrees. So our alpha value, our numerator value is 150, which means when we plug into the right-hand side of the formula, we should be taking the cosine of 150 degrees. Of course, at this point, evaluate the cosine of 150, which is negative square root of 3 over 2, minus that negative square root of 3 over 2 changes to addition. So just as the last problem, add in the numerator, getting a common denominator as required with fractions. Divide by 2 by multiplying the numerator by 1/2. The results are here. And once again, the denominator is the square root of 4, and that needs to be evaluated since it simplifies to a nice exact whole number. Now looking at an example of verifying an identity using knowledge that you already have from previous sections cover, but also incorporating some of our double or half angle formulas. So we're asked to verify the tangent of x over 2 plus the cotangent of x over 2 equals 2 times the cosecant of x. To begin this, we can substitute for the cotangent of x its definition, one of its definitions, which is 1 over the tangent of x. So we're working with the more complicated side of the original identity. And as you can see, the cotangent of x over 2 has been replaced with 1 over the tangent of x over 2. Now substituting one of the half angle identities for tangent. We have the tangent of the angle over 2, and we actually have it here. So making this substitution first, we have it twice. Starting here, replacing that with the half angle identity, sine of the angle over 1 plus the cosine of the angle. In the second location of the tangent of x over 2, replacing it, substituting for it a different half angle identity for tangent, replacing it with 1 over the cosine of x over the sine of x. Of course, with these, trial and error is involved, just as with verifying all identities that we have covered thus far in the class. You keep trying until you come up with something that makes the left-hand side equal to the right-hand side after substituting and simplifying. So, moving right along with this problem, we are here. Of course, here you have a complex fraction, so you would divide to remove it. That would just flip this when it goes to the top. So sine x is now in the numerator. 1 minus cosine of x is now in the denominator. So getting a common denominator for both fractions, it's going to be putting the two denominators together, 1 plus the cosine of x and 1 minus the sine of x. Of course, if we multiply the denominator by something, the numerator has to be multiplied by the same amount. At this point, lots of multiplying, distributing, probably using the 4 method in the denominator to multiply. You could distribute again. And after multiplying, combining like terms as usual, you get 2 sine x over 1 minus cosine square of x. 1 minus cosine square of x can be replaced with sine square of x based on our Pythagorean identity. Sine square x plus cosine square x equals 1. We have sine x over sine x, actually sine x over sine square x. So one of these sine x divided by sine x would cancel. We had 2 of them in the denominator, so in other words, one of them are canceling, leaving us with sine x, 1 sine x still remaining in the denominator, and the 2. The meaning of this is, of course, 2 times 1 over the sine of x, but we know 1 over the sine of x is equal to the cosecant of x, which is a little bit more simplified, because it no longer contains a fraction, bringing over the 2. And the problem is complete. At this point, we have transformed the left-hand side to be identical, which is the requirement, to the right-hand side, so the identity has been proven.